Today we're going to try to make metaballs. And metaballs are something that kind of looks like this. So you have these blobs that can kind of flow together, and you can also subtract them if you want. So let's get started. I already made a folder here. And we're of course going to use Raylib. So let's start by making a little hello world, in which we'll initialize a window. Metaballs. We'll do this. Thank you, Copilot. And we should also define the height and width. And let's also make a run file, which is like something I use with my NeoM setup. So let's compile this, and we need to include Raylib source like this. And we need to also link here, and then we need to link to Raylib, to math, to GL, I think, to pthread, and dynamic linking as well. I think that's it. And then we can run it. So let's go here and run it, and we get a black screen, which is exactly what we wanted. So how do we do this? The metaballs are defined by having a value at each point in space, at each point on the screen. And if that value is higher than some predefined number, then we say that point is inside the ball. And if it's lower, then it's outside the ball. So basically, if it's higher than some number, we draw like red or whatever, and if it's low, we draw black. So we kind of have to have this field. So I'm going to make here a field. And we can also define a threshold, which I think right now will like do 1/2 of the width. And then we need to somehow draw the values of this thing. So to do that, let me actually, just because we're probably going to need it, let me get this one, Raylib. Anyway, so we need kind of like something to draw into. So we're going to draw into this image. And we cannot really draw an image. We can only draw a texture, which is something that is on the GPU. So we're going to say load image from texture. And let's actually make it red. And now we can say, now we need Raylib, because I think it's called draw texture. We can draw the texture, which takes the texture. It takes some position stuff. So it's going to be 0, 0, and the color tint is not going to really matter, so we'll do it as white. So now if this is working, actually we should kind of like unload the texture. And I'm also going to try to unload the image, but that might not work. It is load image from texture. It should be load texture from image, the other way around. Okay, so that worked, and also the program exited correctly. So that's great. Now let's initialize the field with some test values. And here we're going to say for j equal to 0, and it's not going to be 0, it's going to be I plus j. Okay, so then we need to call that over here. And when we get the image, let's also now draw into it. So for that, I think I am going to make it a global variable just for now. Like that. And then we are gonna say update image. And let me just check that it still compiles. Yeah, I knew there was something wrong. And it's here, the issue is. All right. So how do we update the image? Well, we need to do this loop again, loop through all of the pixels. But now the image is, as far as I know, yeah, it's just flat. It's just a flat array. So we need kind of like the index, which should be j times the width plus I. And then let's say, yeah, it already kind of has the idea. If the value is higher than threshold, we can turn it, let's turn it red actually. And then just as kind of a baseline, the color of the image is black. Otherwise, okay, so here we have if the field value is higher than threshold, we turn it red. Otherwise, we turn it black. And then in Raylib there is this draw pixel function, which actually, now that I think of it, maybe we want to use that instead of what I'm doing now. But there should be image draw pixel, which is the one I was thinking of. So we need an image, so that's going to be image. We need a position, X and Y, so that's going to be I and J. And we need the color, which is this. So we can do this, then we update the image, but that is actually not enough. We also need to update the texture. And I think I am then going to need to do this, at least if we want this signature. So let's go ahead and update the texture. And that one is a bit more tricky. Let's go over here and say update texture. We can do this. But the thing about that is it expects a certain format for the pixels. So we're going to say image.data. And I am actually not sure what kind of format the pixels is in. So let's put an assert here. And what do we want to assert? We want to assert that the image format, sorry, the img format is this one. This one. This one. There we go. Sorry, like that, I think is actually what we need. Yes. Because I was looking in the source code about what this thing does, and I'm pretty sure it's kind of expecting that we have this format. So let's try to run that. And now you can see we got this line here. So actually it's kind of a little bit wrong. I kind of wanted to do this, so it's half is red and half is black. All right, so that kind of works. And now we can even do something like if is key released. Key space is fine. Let's increase the threshold by 100. And then I can press space and we kind of like, you can see we're dynamically updating things. So now we kind of have the basic features. Now let's try to actually make a ball. And where is the ball going to be? Why don't we put it in the middle? We put it in the middle. And then what should the value of the field be? Well, one thing that you often see is like 1 over the distance to the current point. So let's get the current point, and actually we'll probably need math for this. So we can do something like this, and I think square root f is fine. And the field value should probably be 1 over distance plus 1, or something like that. We want to do plus 1, so we never get like division by 0. And now the threshold being 800 is not so good, so let's set a threshold of 0.5. So let's see how that works. There is a tiny red dot, I think you can see. So this is kind of like falling off too rapidly. Let's try with 100. Now you can see we got a nice circle going. So let's actually move it back a bit. And let us add one more over here. And now we need to say plus equals. And we probably need to do this. So now we kind of like have the same code running twice. And you can see here, this is kind of the key point. The field is adding together. Let's see how that looks. And now you can see they are drawn towards each other. And let us do this. Maybe something like that. Now they are like even more drawn together. So to make it a little bit more interesting, how about we can control them? So I think for now let's have just 2 balls. Sorry about that. So ball 1, maybe it's just at 0. Ball 2, ball 1y, sorry, it's also at 0 maybe. And we have these 2, and they can be at 400, kind of like in the middle. So this should be, instead of ball, it should be ball 1. And here, that thing we don't need. And here, instead of ball, it should be ball 2. And not like that, please. So ball 2. And let's run that again. So now we have a ball over here, and a ball in center. So let's control ball 1. Let us control ball 1. And we're gonna do that with like WASD. So we need 4 of those, and we're also gonna have like ball speed. And that's maybe gonna be, we should also remember target FPS. So maybe it's gonna be like 100 pixels per second. So we should do 100 divided by 60, which is kind of like the expected FPS. Alright, so some basic controls. If it's W, we do this. If it's A, we do that. If it is S, we do this. And if it's D, we do something else. So here, Y of ball 1 should be increased. So ball 1y plus equals ball speed. And these are very similar, except we have x and minus and minus. Let's have a look. It's not really gonna work because it has to be not released, but pressed. Like that. And that still doesn't work because we have to remember to actually update things whenever we do this. So we're gonna try to just update all the time, every frame. And let's see if that actually is gonna work. To just check things, let's also draw FPS. So we see that we're not breaking things too much. It's actually not working. Because we're not running this function. We also need to run this function, and now we're gonna call it update field. Update field, and we'll need to run that down here as well, like this. So let's see. Okay, it's very it's tanking the FPS, so that's great. And maybe it's not pressed. Key pressed. Has been pressed once. So I want to see if it's being pressed, I guess. So let's try to replace pressed by down. Okay, now it's moving continuously. There is a small bug that these signs have to be flipped. And so this should be Y, sorry, and A should be X, and this should be minus and plus. Okay. And now we can see this effect. Let's speed up the ball. Let us speed up the ball by a factor of 2. Now we can see how they are kind of flowing together and making these very interesting shapes. Let's make it a bit faster, because maybe even more like 10 times faster than we originally had. That's okay. That's pretty good actually. The frame rate has completely tanked, which is a bit sad. I wonder. So so what would we do if we want to make it performant? We would have to use a shader to do it. But we're not going to do that now. We just want to see how it works. So what about if we don't use the square root function? How is it going to look then? Now you can see they're much smaller because the speed at which the function cuts off is much smaller, but will the shape look any different? Well, it's kind of too hard to see. So maybe the starting value will also change that. We'll say start value, and start value can just be like, let's say it's actually 2000 now. Let's try that. So hard to tell, but maybe it's like slightly more narrow. All right, but it's not super interesting, to be fair. So let's put it back and let's do 50 again. Let's put the square root back. Yeah, it's almost like the main effect was just to make them smaller, which, to be fair, is not necessarily so bad. Let's actually keep them like this, and also increase the start value. So this is all well and good. This is all well and good. Let's try to make like a different kind of fall-off function, a little bit more complex one that has a sort of a longer tail. So basically what I want is like this bridge. You can see it starts to form here, but then it cuts off. I want it to form further out without necessarily making the ball much larger, like the ball itself. All right, so it's gonna be somewhat complicated. So let's make a function here, and we'll call it falloff, and it will take a distance parameter. So what we've been doing right now is just kind of like distance squared plus 1. Actually, I want to take the distance squared just for computationally to make it a little bit easier. And now I want to do the following. So this is not something I just came up with. I made a bunch of plots and thought that this might be fun for a metaball. So let's try this. We will need a sigma, which I will say is, what should it be? Let's try to make it like 50. So it's gonna be distance squared, and I'm just gonna do sigma squared. All right, so that is pretty good. Then we're also gonna add 0.1, and then we're gonna subtract something. So actually let's do this is the main part. This is the main part. And then we have the secondary part. That's gonna be 0.1 times 1 minus the exponential of distance squared times, divided by some kind of length squared. And we need to then raise that to some power, and the power is going to be just a variable. So let's do kind of something like this, parameters and calculation. Okay, so we have the sigma, we need some kind of length scale, and if sigma is 50, why don't we make the length scale 200? So it has to be let's make this one sigma squared as well. And then we can just here, we can say sigma 2. Now, but this stuff can then be combined by simply doing main part minus secondary part. And actually we also need the power, so let's say that the power is 8. All right, and that should give us something that kind of falls quite quickly to 0.1. Then it stays at 0.1 for a long time and then goes to 0. So actually, I think with that we want the threshold to be 0.2. And then here we can simply say that it's the fall off of the distance. Same here. So let's see if that works. Okay, so you can see the performance really tanked now, probably because we're using exponentials so much. But now we get this really interesting, I didn't know it would look like this, but you can see it's a much longer bridge, and it quite quickly gets very like fat. And then when the balls are combined, they're actually larger, which it makes sense. It makes sense because they fall off to be half the threshold very fast. But if you combine two balls, of course they make a bigger threshold, make a bigger value in the intermediate region. So you can also get these kind of like long bridges. Let's change it just a little bit. Let's try this, because I'm not sure I like this. Okay, this is very weird. But I think you see the point that you can do very strange functions and get these interesting things. We can even like be even more crazy and like add a how do you write that, ternary part? Let's do 0.1. Maybe this should be, let's try it again. Well, it does the same weird kind of thing. Okay, ternary part. This times sine of f times the distance, and then let's add that. So now we have, yeah, kind of expected something like this. Now there's like an oscillating behavior. And you know what, well, no, we don't need to do that. So you see, that's another thing that's so interesting about these metaballs, is that you don't really define the structure of the ball directly. You just define these numbers that are living everywhere in space. And if those numbers have a certain value, then you are kind of like inside the ball. And that means if you use mathematical functions, you can get these super strange shapes like this, which I think is pretty cool. Now I wonder if we should choose a more interesting color. Maybe we'll do color from HSV, and that should be 360 times maybe the field value. And then, well, let's not do it just like that. Well, okay, let's do it like that. And then mod by 360. And we'll do kind of like this hue and saturation. Okay, it's a terrible green color, but you see you can also get these, you can also do something with the colors to make even more interesting things. How about, now I'm just playing around. All right, let's keep this as kind of a note, but let's not do it. Let's just put red for now. Okay, so we have red, and let's also, just for now, remove this part, and let's do power fall off. So it's going to take a distance and a power, and it's just going to return, let's say 1, that stuff. So we can try that one instead, power fall off, and maybe it can be 2 to begin with. So let's see, let us see how that looks. Power fall of T. Now we have the tiny ball, we have so maybe this should be like 100 times the threshold. Or maybe even 1,000. Okay, but you can also see you can get balls that have different behaviors, different fall-off functions, and that can give you different behaviors. What if we do 0.5? Oh, let's not do that. Although in this case there's not so much to see. All right. I think the last thing that we can do, which would be interesting, is to have a set of balls. So how about we make a, well, we already have vector 2 from Raylib, so let's say balls and balls, and let's make 20 balls. And then here in the update field, we'll loop over all the balls, calculate the distance, this is going to be balls bx. So that should be that, and then we can copy paste this thing and just add it here. So actually we need to be a little bit careful because we don't want to be adding to the field all the time. We want to just add if we're not on the first one. Going to comment this, and let's see if that works. It does not work because we still need this inner loop. So I forgot about it. Loop over pixels. So now they are of course all just in the corner. The frame rate is tanking. So that is not so good. Let's call this 2. But in any case, now we have the balls. Let's actually also give them velocities. And what do we want to do? I guess we do one loop like this, and we're going to say balls B is going to be like this. And we also want to initialize the velocities. And probably using this value. So let's say velocities. Actually, let's get a random value like that. Let's see if that works. Yeah, the frame rate is terrible. Absolutely terrible. So how can we fix that? It's clearly... Let's see if it's in the distance calculation or in the fall off. Yeah, so it's not the distance. The fall off uses exponential functions, so that's probably not good. Let's call this one simple, because it's just gonna return 1 over this stuff. Still gives, because we need to actually use it, so. It helped a little bit, but only a little bit. Frame rate is still very bad. Still very bad. I think, though, that we're not going to bother so much with that. Let's just see that actually works. Okay. So we need to check if bx greater than this. Then we are going to subtract, and now Copilot should be able to do the rest. Looks a little bit crazy, but I think you get the point. All right, that's it for this video, and I will see you in the next one. Bye bye.